Welcome back, everybody. Our next talk is from Boyan from Storepool. Boyan's going to be talking about storage live migration in Apache CloudStack. Over to you, Boyan.
Hi, everyone. My name is Boyan, and I'll talk to you about storage live migration. So this is kind of the where the idea for this talk came from. So we saw some users on the CloudStack users mailing list asking about migrating a virtual machine from one storage to another storage without shutting down the VM in a KVM environment. And the complaint was, CloudStack wants us to shut down the VM to do that. And my agenda is as follows. So overview of what types of what storage types exist in CloudStack, the current status of storage migration and offline and online storage migration, and some new developments that we've worked on in this area. So the types of storages in CloudStack, you have primary storage and secondary storage. And basically primary storage is where virtual disks reside. So these are volumes that are attached to a running virtual machine, or not attached to a running virtual machine, but they can be attached to a running virtual machine at any time. And secondary storage that keeps template snapshots images. Secondary storage is always zone-wide, while primary storage could be zone-wide or cluster-wide. And you have this kind of zone, pod, and cluster hierarchy in CloudStack. There are multiple storage types. So there is local, NFS, Ceph, iSCSI, etc. And KVM is kind of, as you can see from this table, KVM doesn't have as well developed support for the different storage types, for the different primary storage types. So for example, with Zen Server, if you have a nice iSCSI SAN, Zen Server uses something called cluster LVM to give you a multiple kind of the ability to do multiple virtual machine disks on a single one in the SAN. While in the KVM environment, it's supported, but it needs something called a clustered file system. And that's kind of a big obstacle to people, to clouds using iSCSI storage with KVM, for example. So these two, for this reason, because it's not as well developed as with in the other hypervisors, in the KVM ecosystem using iSCSI or fiber channel, storage is not preferred. It is done in a different way, which I'll explain in a second. So these are the storage types. You have local storage, NFS, block, and under block storage, you have the option called shared mount point, which is an iSCSI or fiber channel LUN virtual disk used together with a shared disk file system. And then you have also under block, you have storage systems that support dynamic provisioning in CloudStack. Dynamic provisioning means that a volume is created in the storage system right when you create the virtual machine. It's not pre-provisioned. The volume is created when it is needed. Under dynamically provisioned storage systems for CloudStack, you have the most popular being Ceph, and then you have a bunch of other vendor-specific drivers, which is Storepool and NetApp Solidifier, Daytera, Dinbit, and Dell PowerFlex. It's possible there are some other out of three drivers, but these are the ones we are aware of. Storepool is an out of three driver, for example. Not all of these drivers are in the CloudStack project. So what the options are, in local storage, you have virtual machines that use local block device. Sorry, they use a QEMU, a QCOW image in a local file system, which is usually ext4, and that local file system lives on a local disk or a local RAID array. It has some, benefits and drawbacks. Drawbacks are it has low availability because if a host, a hypervisor dies, you also lose the data on that hypervisor, and you can't restart the VM immediately. You need to fix the hypervisor, and then you can start the VM. It doesn't support live migration, and I'll talk about an exception to that in a minute. It doesn't scale. For example, if you have a VM that needs more storage than you have local in that hypervisor, you're out of luck. If you have some spare space available in one hypervisor, you can't use that space for another hypervisor, etc. It makes maintenance quite hard because upgrading, for example, upgrading the kernel of one host means you need to restart all the VMs there because they're tied to the local storage. Second popular option for storage in CloudStack KVM is NFS. And in NFS, you have a NAS or like an NFS server, an IP network, an NFS export that's attached on each of the hypervisors, and then you get QCOW images inside this NFS export, and they are accessible by all the hypervisors all the time. There is no dynamic attaching or detaching of these images to hypervisors. It's like full access from all hypervisors all the time. Positives, it's very good interoperability and relative simplicity of the implementation, meaning if you just have a highly available NFS server, it makes it very simple to attach that to hypervisors and use it. Negatives, it's relatively slow and high latency, and it has limited scalability because it's still, unless you're building kind of a scale out NFS server, it's limited to the size of one storage repository is limited to the size of one NFS server or one filer. Then on to iSCSI. So this is the shared disk file system option that I mentioned that I don't think many people use. And the reason that they don't use it is that these shared disk file systems like OCFS and GFS are very restricted in the performance and functionality they provide. So the way it works is you have an iSCSI SAN, you export a LUN, that LUN is visible on all hosts, then you build, you format that with OCFS or GFS, and you get QCOW images for each virtual disk inside this OCFS. Drawbacks, it uses these kind of fairly obscure file systems, very limited commercial support. So if you want to get a supported environment with one of these, it's quite hard. And it's fairly low performance. I would say environments built like this would, generally speaking, in my opinion, would get lower performance than an NFS environment on the same network. And very few people use it, which means that there are a lot more issues with it that stay unresolved, right? And finally, we're on to dynamic provisioning for block storage. And it's somewhat slightly different. So it's still block storage. We still use a block storage protocol, say iSCSI, or in our case, we use our own proprietary protocol. In the case of Dell PowerFlex, they also use their own proprietary protocol. We have Apache CloudStack that talks to the API of the storage system, which may be like a storage appliance or a scale-out cluster like Storpool is. And through that API connection, the storage plugin in CloudStack creates, deletes volumes, creates, deletes snapshots, etc. Resizes volumes, attaches volumes to host, etc. One of the differences from the previous scenarios I showed you is that these virtual disks, the LUNs, are not attached to all hypervisors all the time. They are attached on demand. Another difference is that with this kind of storage in CloudStack, we use raw disk images. So it's not QCOW format on the storage system. It's raw disk image format. So all functions like snapshotting, for example, are performed by the storage system itself, and they're not a feature, a function of the virtual machine disk format, right? Like QCOW. So unlike the previous ones, in this scenario, we get one-to-one mapping between a virtual disk and the LUN in the storage system. Positives and negatives. For most of these systems, you can get systems that support dynamic provisioning in CloudStack. You can get commercial support for the storage system. It is a direct block protocol. There are no kind of file system layers on top. It's just block. It's a block storage stack completely end-to-end. Some of these systems have very high performance and very low latency. Others not so much. Some of these systems are suitable for high performance and demanding applications. So, for example, if you run databases in virtual machines, this approach would likely work. An approach like this with the right vendor would likely work better than NFS or than the shared disk file system like OCFS. It's integrated with CloudStack through the kind of a storage plugin and an API connection between the two. So this is a positive because the operations in CloudStack, like creating volumes, creating snapshots, cloning virtual disk, etc., they are just performed out of band by the storage system, meaning CloudStack just tells the storage system, I need a snapshot of this virtual disk, and the storage system handles it instead of being performed in-band, which means kind of reading and writing to the virtual disk in order to perform one of these storage management functions. And this is like offload of storage operations, like snapshotting, for example. A drawback of that is that it requires like a vendor-specific plugin, which might be shipped with CloudStack, or it might be an out-of-tree plugin. That plugin like is a separate piece of code that is maintained usually by the storage vendor themselves. Ceph is kind of different from the previous ones, mostly by the way they attach the virtual disk to the virtual machine. So with Ceph, you don't get a block device in the host operating system. That in Ceph you get the QEMU process in QEMU KVM, the QEMU process talking directly to the Ceph cluster, and they're kind of it's a different approach. I wouldn't say it's a better approach. It's just a different approach. It also creates volumes on demand, and it also has a one-to-one mapping between volumes and volumes in Ceph and virtual disks. Positives, same as the dynamically provisioned block storage systems I mentioned, some of them. Another kind of exclusive Ceph uniqueness is it's vendor neutral. You can potentially get support for it from multiple vendors, from different vendors. Negatives, performance-wise, it's not as good as some of the other systems available on the market. And if you're doing it with a vendor, it's not such a big problem, but if you're trying to do it yourselves, then the complexity of deploying and operating it it's another job. It might overwhelm you depending on kind of the size and the composition of your team. Now on to the main topic, which is virtual machine migration, storage migration. So this is how virtual machine migration works in KVM. You have two KVM hosts with the QEMU process that is the QEMU process of the original virtual machine. You have the migrate virtual machine API call to CloudStack, which in turn performs libvirt virtual domain migrate call to libvirt. And then libvirt talks to the other libvirt, and the two QEMU processes talk to each other to seamlessly migrate the virtual machine from one KVM host to the other, while both the original and the destination, the source and the destination host have access to the same shared storage system. So that shared system might be NFS, or it might be a block device from one of these dynamically provisioned storage systems I mentioned previously. It can be any of the supported storage types except for local storage, because local storage doesn't give you this shared storage paradigm. CloudStack also has another call, which is virtual machine migrate with volume, which allows you to migrate a virtual machine on local storage to another host on local storage. So the kind of moving the data and making sure that everything is in sync is still the responsibility of the QEMU process, but it's one of the features of QEMU that has been exposed through CloudStack, and you can perform this kind of migration from one host with local storage to another host with local storage using the migrate virtual machine with volume API call in CloudStack. Something to note is that QEMU and libvirt have absolutely no restrictions in them in terms of what the source storage and what the destination storage is. It's only a matter of exposing the functionality already available in QEMU and libvirt through CloudStack, so a user of CloudStack can use this functionality in a KVM, CloudStack KVM environment. We'll skip back for a second. So there are two types of storage migration. There is offline migration, which is performed using the migrate volume API call in CloudStack. And this is for volumes which are not attached to a VM. So you have the source storage, and then it does often. So you have the storage, and say for example it's in QCOW format, or say it's in raw format, and then CloudStack would copy this data onto secondary storage, which is usually NFS, and then copy it back from secondary storage to primary storage. And these source and destination storage arrays don't need to be related in any way. They could be different technologies. They could be just different storages in different clusters in the same zone, etc. While secondary storage is for the whole zone. So you can think of storage in one cluster, and CloudStack would take that data, copy it to secondary storage, which is zone-wide, and they take it again from secondary storage to the destination storage. CloudStack can only do this for offline primary storage, which means when there is no virtual machine running. While for online storage migration, the current state of affairs is that it supports fully local to local, and it supports NFS to local with some restrictions, and NFS to NFS with some restrictions. So these are the limitations of the implementations as it stands today. So it's first of all, online storage migration is only available through the API or CLI. It requires the migration of a VM to a different host. So to migrate the storage, even if you don't need to, you need to move the VM as well. And the reason that is not that QEMU can't do storage migration while not migrating the VM, is because it just simplifies things. So you have like a virtual machine with storage migration, and you only support that. We only support that one workflow, and we don't need to do a second workflow, which is for migrating storage without migrating the VM. This is a restriction, but it doesn't matter, I think, to our users. Local to local, there are no limitations. It's supported between clusters in a zone or within the same cluster in a zone. NFS to local is only from zone-wide NFS. Migrations from cluster-wide NFS are not supported. Source and destination hypervisor must be in the same cluster. So there are some kind of restrictions. NFS to NFS, it only supports cluster-wide NFS storage. We haven't looked at why these limitations are in there. The underlying technology doesn't have them. It's just limitations of CloudStack. So what we've released already is migrating from all local NFS, Ceph, etc., to store pool, and we are working on migrating from store pool to everything else. We are also interested to hear, because again, the underlying technology, QEMU, KVM, libvirt, doesn't have any of these restrictions. It can migrate a virtual machine with storage from any kind of storage to any kind of storage. These restrictions only exist in CloudStack. So these are features of QEMU, KVM which have not been exposed through CloudStack. And I'd be interested to hear from you if you'd be interested in having this functionality in CloudStack. I think, given that we've developed everything to store pool and store pool to everything, adding these additional features will not be that much extra effort. We just need to see that there is some interest for them. So I mentioned this workflow, migrate virtual machine, how it works. Migrate virtual machine with volume from local storage to local storage is kind of pretty obvious. You don't need to specify anything more, because they kind of where the storage of a particular VM is obvious. It's in the same host where the VM is. So we've added a few parameters to it, so that you can specify the type and ID of the destination pool. So we've added this migrate to parameter for specifying the destination volume ID and the destination pool ID. So if you have a virtual machine with some storage disks, then for each virtual disk you can specify which destination storage system that virtual disk would go to. Under the hood, it's the work of moving the data from the source storage to the destination storage is performed by the two QEMU processes, one in the source hypervisor, one in the destination hypervisor. These two hypervisors can be any two hypervisors in a zone. They're not limited in terms of the underlying technology. They're not limited in any way. But I'm not 100% sure that the CloudStack would allow you to live migrate a VM outside of a cluster, but the underlying technology allows it, and we can work on teaching CloudStack to do that as well. So in summary, what we are announcing is that we've developed functionality to live migrate storage of virtual machines, primary storage in CloudStack, from everything to store pool, and we are currently working to do store pool to everything else. And we would like to hear from the community. If there is any interest in doing everything to everything in CloudStack. We don't think it's too much work. We just need to hear from you guys and figure out if there is a real need for it, or if it's just an interesting feature that no one would use, right? And let me know if you have any questions.
There are a few. Thank you, Boyan. That was great. There are a few questions coming through. We've got just 4 minutes left, so I'm just going to select some of these. So Rohit's asked, are there any performance implications for doing local storage migration with live VM? For example, a large disk, does it pause the VM, causes a freeze, etc.?
It may. So QEMU, I'm not sure how much of the functionality of QEMU has been exposed, but QEMU has kind of knobs, settings that you can use to limit the impact of storage migration to the storage performance of the virtual machine. So at a minimum, what you're looking at is that while the VM is being migrated, at least some part of its data is remote, meaning it will be forwarded from, let me get to one of the diagrams. It will be forwarded, say the VM has already been arrived at the destination. Some of its data would still be in the source, so the read operation might be forwarded to the source. While this data has been migrated, and this is a network hop, and it relies on kind of the efficiency, the performance of the QEMU storage implementation, right? So you have that overhead while the VM is being migrated, and in addition, you may get kind of the performance of the source or the destination disk saturated by migration, especially if you have a slow disk in a fast network, right? And you can control that by instructing QEMU to perform this migration more slowly, to get it to migrate at a rate that doesn't saturate the source of the destination disk.
Brilliant. Next question, what part of, I guess that means what percentage of StorePool's customers are using CloudStack? Why do they prefer it to other cloud management platforms? If you're allowed to discuss such things, Boyan.
Yes, it's, let's see, it's less than 10%. So it's only like, you can count them on the fingers of both my hands. The ones that use CloudStack fall into two categories. One is managed service provider. So they build both a large shared environment for many virtual machines of their customers, different customers, as well as private environments for each customer. And in the other category is a customer that has built virtual desktop, high-end virtual desktop, meaning with GPUs, virtual desktop service with CloudStack from the beginning, and they chose us because we have a good storage solution for CloudStack. So it was the other way around, and it usually is. When they come to StorePool, they've already made the decision to use CloudStack, either because they've been using it for 5 years, and they then look for a storage system that is a good fit with CloudStack, and they select us. Why did they choose CloudStack over other systems? It's hard for me to know. I really don't know.
So just going to have time for one more question. Michael, Michelle, is just asking: is the store pool CloudStack plugin still under active development? Haven't seen a
Yeah,
commit in the repo for a while.
yeah. It's for whatever reason it's out of tree. We're reconsidering if we want to move it back in the main repository.
Okay, so if people want that plugin, they just need to ping you
Yeah,
guys and
yeah. And
okay.
so we ship it as a jar. So on any build of CloudStack, you add that jar to restart CloudStack, and it works. And we're reevaluating if we want to put it back in the main repository because of the impression it gives people. There are many. There has been a lot of work on that plugin. So, for example, storage life migration to and from store pool is an example of the work we're doing in the plugin.
And I just want to say to everybody here, don't form a bad impression that isn't in the CloudStack repo, because the guys over at Storepool do a lot of work in the CloudStack community and are great supporters of the community generally. Boyan, thank you very much. It'd be great if everybody could give Boyan a virtual round of applause and a thanks. I'll see everybody on the next session, but for the moment, thank you very much, Boyan.
Thanks, Jeff.